Hey students, I hope that you're having a good day so far. I hope that you had a great weekend, and I want you to make sure that you have out these items, your calculator, and your packet from last week. Here's a little announcement. I need for everyone to be quiet during the video. And I've heard from a couple of students in a couple different classes that there are some students who are talking during the video. I would ask that you not talk during the video, please. If you need to ask the person who's covering the class to pause the video or go back, and a lot of people agree with that, fine. But in terms of should you be talking or should you be paying attention, you should be paying attention and not talking at all during the video. So here are the answers to Friday's practice, and if whoever is playing the video could pause so that students could check their answers from Friday's practice. All right, moving on. So I wanted to share with you guys a little news story that just happened recently. The former leader of the Houston Symphony was sentenced to death by electric chair. I'm not sure exactly what his crime was, but it was a capital offense, and he was sentenced to death by the electric chair. And they were going to execute him on February 2nd. But when they flipped the switch, nothing happened. Why? Well, because the former leader of the Houston Symphony was a bad conductor. Okay, I hope you guys are laughing at my joke. Let's move on. Let's talk about electric fields. So this is where your notes begin. Imaginary lines that indicate which way a positive charge would feel a force. That's basically what an electric field is. And a negative charge would feel a force in the opposite direction. So imagine that this picture is an electric field. The electric field is pointing to the right. So which direction would a positive charge feel a force? Well, the imaginary lines indicate which way a positive charge would feel a force. So that's actually pretty easy. It would feel a force to the right. Which way would the negative charge feel a force? It would feel a force to the left. If there is a point charge, which is generating electric field, which, by the way, all charges generate an electric field. There's an electric field around every charged object. The electric field around a positively charged object points outward, and the electric field around a negatively charged object points inward. Why? Well, imagine you put a positive charge right here, it would be repelled from the other positive, so therefore the arrows are pointing away. If you put a positive charge next to the negative charge, it would be attracted, so therefore the lines point inward. Again, electric field lines point out from positive, and electric field lines point in to negative. A little bit more about electric field diagrams. The more lines, the bigger the charge. That's important for you to write down. And the higher density the lines, the stronger the field. Meaning if the lines are close together, that's where the field is strong. If the lines are farther apart, that's where the field is weak. Also, I want you to know that field lines never cross, because if they did, that would indicate two different directions, and that wouldn't make any sense. The force that a positive charge would feel would only be in a specific direction, and so not in two different directions. All right, let's look at our example. The first question that we want to be able to answer is, what is the sign of each charge? Well, what tells you the sign of the charge is whether the arrows are pointed in or out. So, is it in or out? Well, looking at these two charges, we see that the lines are pointed in to both of them, meaning that they are both negative. Which charge is stronger? Well, the one with more arrows is stronger, so that means Q2. Look at points A and B. So here's A, here's B. We want to answer the question, is the field stronger at point A, or is the field stronger at point B. How can we tell where the field is stronger? We can tell if the field is stronger by looking at the closeness of the lines. So we see that the field is stronger at A because the lines are more tightly packed at A. All right, if you put a positive charge at point B, what direction would it feel a force? Well, it would feel a force in the same direction as the arrow because it's positive. If you put a negative charge at point B, it would feel a force in the opposite direction because it's negative, meaning it would go away from the direction that the arrow is pointing. All right, looking at a second example. Since it's pretty clear, I'm just going to go ahead and leave this up. That way you guys can check out all the answers to the example at your own pace. And that's pretty much the end of the lesson. So go ahead and check out this example and then begin on your practice right away. Have a great day.